Hi, my name is Novina Shakila binti Muhammad Nazir and my ID number is 201209102. In calculus, differentiation is one of the two important concepts apart from integration. Differentiation is a method of finding the derivative of a function. Differentiation is a process in math where we find the instantaneous rate of change in function based on one of its variables. The most common example is the rate change of displacement with respect to time called velocity. The opposite of finding a derivative is anti-differentiation. It can be done using only algebraic operation, 3 fundamental derivatives, 4 operational rules, and an understanding of how to handle function. What is maximum and minimum problem? Maximum and minimum problem is to find a maximum and minimum element from the given array. We can effectively solve it using divide the conquer approach. In the traditional approach, the maximum and the minimum element can be found by comparing each element and updating maximum and minimum values as and when required. Why we use applied maximum and minimum problem? The process of finding maximum or minimum problem values is called optimization. It's trying to do things like maximize the profit in a company or minimize the cost or find the least amount of material to make a particular object.
Assalamualaikum, I'm Nur Izzati. Let's look at the first problem statement. A rectangular door with semicircular top is to have its height as y, given y is 12 minus 2x minus pi x over 4. Question 1 Roman asks us to show that the area is 24x minus 4x squared minus pi x squared over 8. First, we write the information we have, which is value of y. And then the area is actually given by the area of the rectangle plus the area of the semicircle. Please note that the area of the semicircle is actually 1 over 2 pi r squared with r substituted as x over 2. So now we're gonna simplify this and get xy plus pi x squared over 8. Now we're gonna substitute the y with the given value from the question and we're gonna expand the x inside the bracket. Okay. We want to combine these two fractions into one, so we're gonna multiply the numerator and denominator of this part by 2 and get 24x minus 4x squared minus 2 pi x squared plus pi x squared over 8. Simplify this and we get the final answer 24x minus 4x squared minus pi x squared over 8. So we actually proved the formula from the question. For question 2 Roman, we are asked to find the maximum area. So in order to have a maximum value, we need to have our second derivative less than 0. Okay, so first we write the formula from the question, which is A is equal to 24x minus 4x squared minus pi x squared over 8. And then we want to differentiate this, so we have dA over dx equal to 1 over 8 in the bracket 24 minus 8x minus 2 pi x. So step 3, we're gonna let this dA over dx equal to 0. Bring 1 over 8 to the right hand side, so we get 0. So we're gonna bring 24 to the right side and we have here 8x plus 2 pi x equal to 24. And then we have to factorize the x, so we'll get x open bracket 8 plus 2 pi close bracket equal to 24 and we have the value of x, 1.68 meters. And then step 4, we're gonna check, does this value will maximize the area? Okay, so we'll have to find the second derivative by differentiating the dA over dx and we'll get 1 over 8 in the bracket negative 8 minus 2 pi. So press this in your calculator and we will get negative 1.79. We know that the value is actually less than 0, so it will maximize the area. Next, we'll have to substitute the value of x here, which is 1.68, into the formula in step 1. Press in your calculator and we'll get the final answer 2.52 meters squared.
This is the example question for minimum problem. A closed can in the shape of a right circular cylinder of radius r meters and the height h meters has a volume of 16 meter cubed. A. Express the surface area A in terms of r. The formula for area of cylinder is 2 pi r square plus 2 pi r h and this is equation 1. In this formula, we have two variables which are r and h, so we need to replace h in order to get the surface area in terms of r by using the information given. Here it shows the volume is 16 meter cubed. The formula of volume of cylinder is pi r square h. So pi r square h equals to 16, then h is equals to 16 over pi r square. And this is the equation 2. Next, put equation 2 into equation 1. So it will be 2 pi r square plus 2 pi r in the bracket 16 over pi r square. Expand and the final answer for A will be 2 pi r square plus 32 over r. Next, for question B, find the radius of the can so that the total surface area shall be a minimum. First, we need to find the first derivative. So differentiate A equal to 2 pi r square plus 32 over r into dA over dr. The answer will be 4 pi r minus 32 over r square. Let the first derivative, which is dA over dr, equals to 0, which means 4 pi r minus 32 over r square equals to 0. And the answer will be r equals to 2.929 meter. In order to know if it's minimum or maximum, do the second derivative test, which is differentiate the first derivative. It will be second derivative of A with respect of x equals to 4 pi plus 64 over r cubed. Insert the value of r and the answer will be 15.11, which means it is greater than 0. If the second derivative is more than 0, then x is a minimum value. So the final answer will be r, which is 2.929 meter, is a minimum value.
Lastly, I will tell you guys about the conclusion of our presentation. Application of differentiation is an important concept of solving maximum and minimum problems. Differentiation is nothing but calculating the rate of which its quantity changes. It is the slope of the curve of a particular function, and to understand the use of differentiation in real life, you must understand the basic meaning of differentiation graphically as well as theoretically. To give a simple example, the cooling of ice. We calculate the change in temperature concerning time. For all such example of real life, differentiation is a method to calculate required value at certain points. Other than that, one's easily measured or calculated. The most common use of derivative is finding the maximum and minimum values of a function. To find the derivative, we have to let the derivative equal to 0 and find the value of the variable. Next, find the second derivative. If the second derivative bigger than 0, it is the minimum value. Meanwhile, if the second derivative is less than 0, it is the maximum value. Lastly, a minimum has been found by substituting the x value into the surface equation. Thank you.